Hello, Internet. I'm Evan Dashevsky, features editor with PC Mag. Welcome to The Convo. Okay, today we're going to talk about civilization, specifically how it's become so complex that we need tools like artificial intelligence in the background just to kind of keep it all running. It's kind of like Skynet, but hopefully more benevolent. We'll learn more about that. Okay, so now you at home, you may have probably had some interactions with artificial intelligence, maybe things like Pandora Radio recommending a song or a Google search that kind of already knows what you're looking for before you're looking for it. But advanced forms of AI are increasingly becoming the invisible force behind the scenes that literally helps keep the lights on and kind of keeps civilization running. Okay, so to help us learn a little bit more about these invisible forces that are running the world, that's literally true, and also where it's all going to be going in the future, I'm happy to bring Dr. Colin Paris, the Vice President of GE's Software Research Division. Dr. Paris, welcome to The Convo.
My pleasure.
Okay, so now for those of you at home, the show is called The Convo, not The Dialogue. So if you have any questions, ask them in the comments and social people will read them off throughout the show. Now, if you're watching this after the fact, you're listening to the podcast and you still have questions, may I recommend Wikipedia, because no one else is going to be able to answer that. Okay, so Dr. Paris, it's in the news. Your work for GE, are our microwaves spying on us?
No, they're not.
Okay.
They're not.
Okay.
Definitely not.
Convo exclusive, microwaves are not spying on you. Okay, but for most people, when they think of GE, they probably think of things that they have in their kitchen, but GE does a lot of like industrial stuff that keeps the world running. Exactly. Okay, so you are on the software research division, you're the head guy here. So what exactly does your team work on? What kind of projects?
Well, basically, we work on a lot of big data and analytics projects. Mm-hmm. So if you think about GE, we build assets that last a long time. Uh-huh. So you've got a jet engine, it's there for 40 years. You've got a steam turbine, 30 years. A wind turbine, 20 years. A locomotive, 20 years. Mm-hmm. Each of these things have to be serviced, and you want them running as best as possible so that they're safe and they're up as long as possible. Well, I'm taking the data that comes off of these systems, using analytics to figure out when they're going to break, prevent them from breaking, or if they do have to come in for maintenance, make the maintenance time as small as possible. Right. And that's what we do, using the analytics and big data.
So you're using things like, one of the things, the tools I've heard a lot about, and I think you work with it, is machine learning.
Yes.
What is machine learning?
Well, essentially what machine learning is a way to take a lot of data and find the patterns in the data. So we have a pattern. We know a pattern looks like this when you have a failure. Right. Or a pattern which is a set of sensors. The values all look like this when you're about to see a security violation. Well, let me look for that pattern. And if I can find that pattern or find it even before it's formed, then I can say, I know I'm going to have a failure. Okay. I know I'm going to have a security violation. So that's what big data is really about. Finding the patterns in the data that allow us to predict things that are going to happen and to optimize things so we can get it done as best as possible, as cheap as possible.
Okay. And one of the other tools that I think I've seen you speak about online is the digital twin.
Yes.
What is a digital twin?
A digital twin is a digital representation of a physical asset. Okay. It's a model. Right. It's a model of the asset that allows us to do three things. Allows us to use the data to give us an early warning about when that asset is going to fail. Okay. It allows us to predict how much life we have left in the twin before we maintain it. Right. And it allows us to do things like optimize what we can do. How do I get the plane to fly with the least amount of fuel cost? Right. Or the locomotive to get there with the least amount of emissions.
Facebook, I see you have a question.
So we've seen a lot of great AI applications for business. When do you see AI hitting the mainstream for consumer software?
Oh, I think AI is in the mainstream for consumer software right now. I mean, you look at a Google search, what you have in a Google search is AI trying to predict for you as you do the search what's the thing you're really asking about and give you the best possible answers. When you see Amazon right now and you're asking Amazon to show you shirts, they're trying to predict for you the best shirts you like. You know, same thing with ads. When the ads are being produced by Google, that's AI just giving you the right ads that are most suitable for you.
It's almost like a digital twin, kind of like an imagination of the machines. Would that be correct? Okay.
Yes, it is. But it's an imagination that's actually centered around what it knows. The past history it's had, and some of the things it knows about the environment and how you're using it. And that imagination tells it, well, I guess based upon this, I may have to be maintained at this time.
Is it what kind of reliability and how accurate is it?
You see, the good thing about the twin, before we always built models. Right? But now what we are doing is making the models living models. Right. So every time the plane lands, I take data from the plane. I take data about not only how the plane was used, but
Yeah.
about the environment it was in, where it flew, what was the temperature, what's the pressure, the dust level, and I changed the model to really reflect something that's happening in the engine itself. So now I have the most accurate model possible about that engine itself. And so now that makes it a lot better. So I can predict things a lot better.
Now, using these sort of technologies, now, if we were bringing this to the consumer end, because you're working on the more industrial end,
Yeah.
but would it be able to would it make a model of a turkey when you're cooking at Thanksgiving to tell you exactly when it's going to be done? Can it be, will the average consumer
Yeah.
see digital twin technology in their daily life?
Oh, I think so. I think
so?
they see it right now.
Yeah,
I mean,
yeah.
they see it in some of the examples I gave before, but
Yeah.
but things that'll happen. So, for instance, if you could bring it into ovens,
Right.
I can tell you a little bit before when your oven or microwave might break.
Yeah.
By looking at the things in it, I can tell you when you have to get it serviced.
Right.
Many of us don't realize we need to get the fridge serviced. We need to get the cars. They're in the cars right now.
Right.
It'll
Yeah,
tell
yeah,
you
yeah.
when you have to bring in the car to get serviced before.
Right.
It'll tell you when you're about to have a failure and bring those cars in. So it's helping us already.
Okay. Facebook, I see you have a question.
What kind of safeguards are in place to prevent a machine from taking over mankind?
Great question.
Yeah.
We're going to get a lot of sci-fi weird
Yeah.
questions, just so you know. But
Yeah, that's all right. So when you think about a safety system, you want to think about levels in
Yeah.
a safety system, right?
Yeah.
Because, so for instance, you have the cyber level, which is I have a firewall that prevents people who are not authorized from coming in.
Yeah.
Then we have something called digital ghost.
Okay.
So what that is that because we're GE and we build these machines, we know the physics that actually drives these machines. By physics, I mean, you know, there are parts that have to make sense, right? Based upon the type of material we have, I can tell you how hot it could be inside that combustion chamber. So we have these sensors, and these sensors tell us that this is the heat that should come out of each sensor. So if you try to actually fake the sensors and say these 3 sensors are 20 degrees, but these 3 are 200, I'll know you're lying.
Right,
Because you
right.
can't fool physics.
Right.
So we're using, that's called a cyber physical system.
Right.
It has both the firewall piece and the physics piece tied together. So we're using these layers to try to prevent people from coming in and hacking the system. So that's the first thing. So somebody hacking it. The second thing is this notion of the machine taking over itself. There are certain things we don't let the machine do.
Okay.
You have a control system. The control system is allowed to do certain things with the machine. Certain things it's just not allowed. So we can stop it from getting to that point from just simply going off track and doing these very weird, very dangerous things.
Right.
So we put a number of safeguards in place. Now, we don't think it's going to be perfect all the time. So you got to continuously bring people in the loop to examine new things that show up. You got to continuously look at proactive reports. If you find out that there's been a hack and they publish information of what the hack is, you got to upload that software to protect it. So it's a continuous journey
Yeah.
whereby the machine is working on it, the humans are working on it, all to safeguard ourselves.
Now, one of the things that's a hot topic on this show for anyone who's watched your stuff is technological unemployment. Whereas our machines are so good, you are a little too good at your job that these sort of systems can replace more human jobs than they bring on. Do you think about that at all? About like how far away from a kind of like employment apocalypse that you are too good at your job and that too many other human workers are just not necessary? Where do you think that's all headed? Or is that something we should be concerned with?
You always should be concerned with
Yeah.
these things, right? So I think about these things in 3 ways. So the first way that I look at it is that there are some jobs that are dull, dirty, and dangerous.
Right.
I want to make sure that we don't have humans too often in those jobs. Let me give you an example. So we have oil rigs that sit in the ocean.
Right.
And there's a stack, and that stack is used to burn off the fuel, the oil that you get out of the ocean bed. Somebody has to go up that stack and see if it has rust on it. That's 200 feet in the air. You have people hanging by ropes. There are gale force winds that are blowing. The chances of a mistake happening
Yeah.
are huge.
And that's where the in the Gulf, where that
Yes,
explosion,
exactly.
that was an explosion in the ocean.
Exactly.
Right.
So now we have drones.
Yeah.
The drones fly a circle. The drones take pictures. We use software. The software analyzes where the rust is. The software figures out where the damage is. I haven't put humans in a dangerous place.
Right.
The same thing when I'm looking at wind turbines. So now we're going to renewables, right?
Are they dangerous?
Well, no, the wind turbines are
Yeah,
good,
yeah,
but the
yeah.
wind turbines are 200 feet in the air.
Right.
So when you have to go up to replace that,
Yeah.
we get mountain climbers.
Right.
We find people who are mountain climbers who do this.
Yeah.
Now, how many mountain climbers can you find willing to? Very few.
Yeah.
And the people you have up there who are trying to do it,
Yeah.
if they have a bad day, those are lives.
Yeah.
So we spend a lot of time working on that. So those jobs I want to replace.
Right.
Then there's the notion that, all jobs will be replaced. Well, it's not true, because as we add new things,
Mm-hmm.
as I connect these things to the net, I have more complexity.
Right.
I now need a human because new things are going to happen I never thought would happen.
Mm-hmm.
So I can't possibly program that in because we never experienced it before. So I need a human there.
Mm-hmm.
So it's the humans and the machines working in symbiosis, working together.
Mm-hmm.
So I think there'll be much more jobs in which the human is working with a person.
Mm-hmm.
Now I'm not naive. There will be jobs in which we have gotten them to a level in which you don't need as many humans. What we have to do is figure out how to retrain these humans to the point in which we move them on to the more complex jobs. So it's going to be a translation, and we've seen it.
Yeah.
We saw it in the factories as the factories got more complex. We saw it in the fields when people worked in creating crops and growing crops. And then it got to a point where you had better fertilizers, and so you needed less people. We had to transition to something different. The
Yeah.
same here.
I mean, one of the amazing facts that I bring up a lot is that people say, like, American manufacturing is in disarray. Actually, American manufacturing is doing really good. We produce more stuff today in the U.S. than we did in the 1970s. We just employ about a third as many because the machines have become so good. But at the same time, the employment level is not where we'd all like it to be, or the participation rate. But it's not in a dire place. So we've kind of made a transition, but it hasn't been as dire as some people have predicted it would be, and so maybe it's not going to be so dire in the future. Who knows? Facebook, you have a question.
Do you think machine learning and AI will help to make driverless cars safer than manned cars?
Yes. Well, look like you would answer that. Yeah.
Yeah, I think so.
Yeah.
Here's what we've seen, right? I mean, and we've seen some people use the techniques. What happens in a driverless car is that as a driverless car is moving around, I can give you many examples, but I think Google, Tesla, quite a few have this capability. So the car is driving on the road. As the car comes off the road, you still have a driver there. The driver themselves, normally they have these Mobileye systems, and the Mobileye is looking for 2 lanes in the road. If you're in a country road with 1 lane, the car may veer a little bit away. The driver corrects, right? If you get to a complex stop sign, in which one of the stop signs are tilted that you can't see something, the driver's still in the seat, the driver adjusts. The car is learning with the help of the driver, right? Now think about it. If you look at just Tesla cars, cars with auto, the number I think Dave talked about with the enhanced auto capability was something like 280 million miles. So they've driven on many more roads and had many more experiences than one single driver, because they're pooling all of the miles of every single driver, all of the adjustments that the car is learning. Tesla also actually talked about last year 1.3 billion miles it's recorded. Now, when they record all that data, what do? They put it in these big machine learning things, and these big machine learning machines begin to figure out some facts. Here's the facts they figured out. When a ball falls in a road, a little boy follows it. So the minute you see a ball in the road, slow down the car. When a dog runs in the road, a human follows it. The minute you see a dog, slow down the car. Right? So now the car is now learning how to drive on many roads that a normal human wouldn't drive, and the car is now learning every time it sees a dog to actually stop the car, every time. Not if it's tired, not if it's cold, not if it's drunk, not if it's somehow incapacitated. So you have systems in which the amount of learning that's going on, because it's not just one driver, it's every driver. Their experience comes together. They're learning a lot faster than we are. So just by the fact that every driver experience is pooled together, the car is better. Then the simulations show the car situations that you as one driver would never experience in your life. So the car itself will get progressively better just by these systems, because it's taking all the knowledge from us and it's taking the knowledge of the simulation. Does that make sense?
Yeah. Well, let me ask you this. Is there anything that these systems would not be able to do that only a human can do?
Yes, there may be situations in which, like the one in Google that was interesting to me was there was a person in a wheelchair leading a duck.
Okay.
right? And so there's a person in the
They
wheelchair
were trying
driving
to
around.
trick the machine, I'm guessing.
This
Okay.
is San Francisco.
Okay,
you know.
sure.
You know, and they're following the duck and
Yeah.
this person, and so the car is trying to figure out. It looks like some object. Look, it's not a dog. It's a duck.
Yeah.
With a person in a wheelchair. That's a difficult one.
Right.
So what do you do there? You'd love to have the human still sitting in the front of the car
Yeah.
saying slow down, because it can't recognize that.
Yeah.
And it takes a while to learn. In the early days when you'd be riding on your bicycle and you stick your hand out to indicate you want to make a left turn, in many cases the system couldn't understand that you were sticking your hand out for a reason. So there'll be subtle signals that a human being could recognize. Somebody on a bicycle has a problem and is shaking. Maybe they're going through some type of medical emergency. The car won't recognize that. But a human would recognize something's wrong with that person. Let me slow down because he may fall off the bike or she may fall off the bike. So there'll be situations like that we'll have to deal with.
Facebook, you have a question.
When will we get to a point where we are no longer designing new algorithms? In other words, the machines themselves are just self-improving with the
When are they going
algorithms
to
that
replace
they are
your
writing?
job?
Oh, yeah.
Yeah.
That's happening now.
Okay.
Because the algorithms we have can learn in 4 ways.
Okay.
So they learn from the data they bring in. So a digital twin
Yeah.
brings in data. Every time the plane lands, it has a snapshot. It collects the data from how it was being used by the operator, how it was, the environment it was flying in, and the conditions in the engine itself.
Right.
So it can learn from its own data. It can learn from the fleet. The minute another plane that's similar to it detects a failure, and you understand what that failure is, it sends the information across. So the plane's learning from the fleet. The plane's also learning from simulations. We collect a lot of information. We have these systems that we build in Predix, and we'll run simulations at night saying, what if this happens? What if this happens? What if you get gale force winds? What do you do? So it's learning from simulations, and then it's learning from humans. When we detect something we don't understand, we send it to a chief engineer. The chief engineer will write a report on what they think. We mine that data and pull that information out. So these systems, these algorithms are learning and getting better because they're learning from humans, from the fleet, from their own data, and from simulations. So they will get better than us, just like the Tesla car.
Right.
And that's what we want.
Right.
I would love to have that ability in which something can help us save lives. And that's the key.
Now, how much power should we give machines and algorithms to make decisions? And I said you don't allow the algorithms to make decisions. Is that because of security concerns, or you actually don't trust them to make the correct decision?
There are 3 concerns we look at. The first is some measure of security.
Right.
Because you have to actually, believe it's operating in your best interest, and so there are reasons around that. Second is the level of risk. There's risk in this business risk. Do you want to undertake pure business risk? And I think in many cases, for instance, the planes.
Right.
In many cases, the planes can run on autopilot, but you have pilots in there because you don't want to actually have that risk to lives and to businesses. So you want to think about it from that perspective, right? The third risk you want to look at is the security overall. You need someone there in the event that something happens that's very unpredicted, like the duck example I gave, but in a real, catastrophic case.
Right.
So you're looking at the security, you're looking at the safety, you're looking at the business risk. Those are 3 levels of risk where you'll never want to be without that kind of sort of overarching view. And remember, I think of the world in terms of synergies, mind and the machines, the humans and the machines getting better. I don't see a point of the machines getting better by themselves or the humans getting better themselves. The humans are learning from the twin. The twin is giving us so much data that we are saying things like, I'll design the machine differently.
Right.
We can ask the twin at times, tell me how much fuel you used in the last 2 years, give me a projection of what it'll be in the future. And then I may say things, but like, you don't know some extra routes I'm planning to add. So again, the human, the mind, and the machine working together.
I saw some live presentation that you did. We were actually like talking to the twin of a turbine or something, which was it was kind of interesting. The interface was actually like you were talking to a living entity. So, I mean, I don't want to go too far into sci-fi territory, but like, or perhaps I do. Using this like digital twin technology, do you think we could be able to map and duplicate a human mind and kind of like, be able to talk to that, a virtual human mind?
Yeah, well, in the right context, because the example you saw was just that. So, we can map these things with the right dialogue. So if you look at that twin example, what occurred was the twin called me and said, I have a problem.
Right.
Then I said, well, tell me what's the root cause of that problem. What caused it? The twin tells me that.
Yeah.
Then I say, give me two alternatives. It gives me two alternatives. Then I say, well, tell me how you got to those alternatives. What data did you use? And then I said, give me the business value behind which one I should choose. And then I chose one.
Right.
That's a dialogue. A set of things in which somebody says there's a problem.
Yeah.
Somebody says, here's what caused the problem. Here's some alternatives. And I pick one.
Now, that was aspirational, or that technology exists?
Oh, that's a prototype.
It's a prototype, okay.
Yeah, prototype
yeah.
for us, meaning there's a limited environment in which we can use that. That, I believe, makes sense.
Right.
Because that sequence of things are things that 80% of the humans would do.
Right.
I have a problem with a machine. What's the reason? Give me some alternatives. How can I fix that?
Right.
That's the type of dialogues we want to drive. In that context, AI can help us. Now, can AI be broad enough to help us in every possible thing? That's more difficult for me to determine.
Right, right.
But we've been focusing on that context itself, and in the context, yes. You know, we can have these dialogues. We have the same dialogue with a developer. A developer might say, in order to build this thing correctly, what are the 6 steps I follow? And they may get those 6 steps from looking at one of the best designers or developers in the world. So you can take a best practice, put it in a sequence of steps, and learn from that, and the machine can emulate that.
Facebook, I see you have a question.
What kind of advice would you give to people who are looking at AI and all like the sort of ways it can disrupt the job market, and they're wondering about like, well, is my job going to exist in a
Yes.
decade or something? So what should they do to really prepare for that sort of future?
If you think about it, there are 3 types of sort of companies working in this space.
Yeah.
There are companies that own the data and are using the AI to get the experience better.
Okay.
So if you're thinking about your job in that area,
Are you saying like
then-
the Google sort of?
right,
Yeah,
the
okay,
Googles,
okay.
the
Right, right,
Amazons,
right.
they
Yeah.
have the data.
Yeah.
They're using AI to create a better service.
Right.
Right. So
And
embrace
to
that.
sell you services.
Yes.
Yeah.
So embrace that.
Yeah.
If that's where you are, or that's the thing that you're thinking about,
Mm-hmm.
go embrace those capabilities. The brilliant thing about now
Mm-hmm.
is I can go and look at a variety of MOOCs, online courses
Mm-hmm.
about AI. I can go and learn about how to write some AI programs. I could put my code in GitHub. I could become a professional.
Right.
This is not something that's stopping me from easily doing
Well,
it.
actually, that's an interesting point. So you're also kind of like an executive. Would you feel comfortable hiring engineers who say didn't go to college but have shown they're very good with algorithms?
Oh, we do it now.
Okay.
There are people who, you know, for years have shown up and have said, I've written this in GitHub.
Yeah.
They are one of the best contributors to open source projects. That body of work speaks for itself.
Right.
Right? I mean, they've done this for years. They've tested the open source. The open source work they've done are generating hundreds of millions of dollars.
Yeah.
It's not a discussion about college at
Yeah.
all.
Do you think college is going to go away? 'Cause
No.
No.
No, I think
Yeah.
2 things in college. I think
Yeah.
there's a way that you can structure your learning experience, especially if you don't know what you want to be.
Right.
Right? Because you get exposed to a number of things. Then also, I think innovation in the future is going to be the long tail. By that I mean you're not going to innovate by just knowing one space. Now, when we look for certain types of people who have ideas, we may look at a problem and then realize the biologists who looks at biological systems had models that solved these problems years ago. Can we learn from them? Years ago, we were watching a problem in which we were trying to look at the heat inside, in the back of computer systems, high-performance systems. Then, while we were doing this, a friend of ours showed up and said, you know, this looks a lot like what the ants do in Africa. The ants in Africa build these very tall tunnels up in the air, these anthills.
Yeah.
But in the middle of the tunnel at the bottom is exactly 86 degrees.
Wow.
It could be 102 outside or 108 outside, it's always 86 degrees. And these tunnels are connected with the right airflow.
Wow.
That gave us an idea about how we would want to build computer systems to have the right airflow. A biologist helping us. So the other reason you go to college is get a breath.
Yeah.
Because the innovation may come from a field that's not related to the one you have.
Okay, well, that's actually another thing. I'm a defender of the humanities. I know that STEM is where we should kind of like be putting our resources, and as a parent myself, you know, STEM is something we want to incorporate. But I don't know, I'm a little worried that we are pushing, we're taking out the arts, the history, the humanities, and I feel like, you know, that's going to actually come up with worse technologies in the future. Something like Apple, I think, is a perfect example.
Yeah.
You know, Steve Jobs always said it's the mix of,
Calligraphy.
yeah, that was his one course that he took in college, was calligraphy, is that, you know, when we get too far away from the humanities, the STEM needs the humanities to make the technologies human. So I don't know, well, like as someone who's very analytical and works in this field, I mean, like do you see and for someone who doesn't even do the kind of consumer-facing stuff, is there a need for the humanities in even the work that you do?
Yeah, I see
Yeah.
quite a bit. There are two things that I think that show up that become quite interesting. The one dimension is the design itself. So you have notion of art and calligraphy and graphic
Right.
arts right now that actually relate to how the user interfaces look like. So that's a good dimension. The second dimension really is in the business and the ecosystems around how things are built. So right now, when you think about how software is being built, no longer is it being built by one company. There's open source, there are open innovation projects. How do these ecosystems work together? When you go back in history, you realize that people had different ecosystems in place as they went through farming communities, as they went through a variety of things in different cultures. That knowledge and learning gets applied in a variety of ways. The other aspect of humanities that are interesting is cultures. You know, multiple cultures view things and perceive things differently. You have to understand that culture to understand what it's going to perceive and how it's going to be using the AI in certain ways. If you lose the ability to understand a culture because you haven't been exposed to it by the humanities and other things, you lose a lot.
Right.
So I think there's a number of subtle ways that this thing contributes.
Yeah.
And you see it reflected in everything we do because we are becoming a global, more and more a global planet.
Or less and less in the last few years.
That's-
We'll leave that to the
Yeah,
side.
long discussion.
Okay, so we're actually, this has been a great convo, but we usually wrap it up with a few fun questions. So just for technology, do you use Windows or Mac?
Mac,
Mac, okay. Android or iOS?
iOS.
Oh, you're Team Steve Jobs. Okay, have you recently come across a piece of technology that made you think, wow, I'm really living in the future?
What would be the one that I would say that? I'd hate to say that, but Tesla.
Tesla,
their
okay.
car.
Do you have a Tesla?
Not yet.
Not yet, okay.
Not yet.
Yeah,
but
yeah.
if I look at the enhanced
I want one
autopilot,
too. Yeah. It's
you
cool.
know, the fact you can summon the car,
Yeah.
on the phone and the car comes and finds you.
Yeah.
I like that.
Yeah,
It's
yeah.
interesting.
It's super cool. Yeah.
Yeah.
Where do you get your daily news and information from?
I use a variety of sources. I worry about the fact that sources right now are becoming too biased around
Yeah.
a point, and this is the thing that worries me quite a bit. So I troll a variety of sources. And then, I have this one technique I use that says, there is going to be sort of synergistic randomness.
Okay.
As I look at different articles,
Yeah.
I often wonder about the points that they have that are just something I wouldn't normally look at. So I choose once a week to look at a site that I would never look at
Okay.
because somebody decided to send me either, a tweet or somebody decided to send me something randomly stupid.
Okay.
And I deliberately say that's stupid,
Yeah.
and I'm going to look at the site.
Okay.
Now, funny enough, when you go to the site and you hear their description of things, you
Yeah.
get a different perspective.
Yeah.
And that's my way of sort of exposing myself bit by bit. It only works half the time.
Right,
the rest
right,
of
right.
the time, it's
Can,
just utter
can you
nonsense.
please give me one example of going to a stupid site and then learning something? Is there anything you could share with us?
Yeah, so there was one time I was looking at trips around I was trying to take a trip with my family. My
Yeah.
son always loved the fact, that we should go to Australia.
Okay.
Right, so I'm looking up these things here, and then a stupid discussion, shows up next to me in which someone, it appeared to be stupid to me
Right,
because,
right.
They said, come see Washington D.C. on a Segway, and I'm thinking, why would I go on a two-wheeler thing,
Right.
to see something?
Yeah.
And as I dug deeper and deeper,
Yeah.
what I discovered is that these things are very interesting. I end up doing a Segway ride in the
Okay.
forests of Tasmania, looking for Tasmanian devils and finding them on a Segway with large off-road tires.
Right.
Stunningly brilliant.
Okay.
Never thought I'd get there.
Yeah. The moral is embrace stupidity.
Yeah.
Edward Snowden, traitor or hero?
Wow.
Yeah, that's a tough one.
Yeah, that's a very tough one.
If you don't have a strong opinion on that.
I do.
Okay. Will the singularity occur in 2054?
I hope not.
Hope not.
Yeah, but you
Yeah.
see, I hope. I
But then
don't
you get to
think
live
so.
forever.
Yeah, I think there are too many things that there are too many pieces of this thing that are not fully understood for that to occur, right? As well as, remember, I live the technology myself, so
Right.
I understand even when I put the technology out there, how many true gaps there are in the back.
Right.
It's nothing like the cook to understand exactly how the meal was made and what's in the meal, and so there are a lot of gaps there yet. I mean, so. No, the one point I do understand is the fact that because we're interconnected with machine learning, we are learning 10 times as fast. So
Right.
what we would normally learn in 100 years, we're learning in 10 years.
Right.
So I could understand why people would think what they're thinking. So in 20 years would be what we would normally have learned in 200 years. So we are rapidly approaching a certain level. The real challenge is, are we maturing at that same rate? Right, in terms, see, and that's
That's
the
another
thing.
discussion. Yeah,
because
yeah,
it is about the mind of the machine.
Right.
You know, and we've got to find ways to pull that together.
Sure. Is there intelligent life out there somewhere?
Oh, I definitely believe so.
Definitely believe so?
Yeah.
Okay. Is Bigfoot out there?
Something with big feet,
Yeah.
more than likely. Yeah, the probability is yes.
Well, you're originally from Trinidad, right?
Yes, I am.
Okay,
Yes,
there,
I am.
Do you have Bigfoot down there, or is there a different monster that people talk about down there?
There are a variety of little
Yeah.
monsters. They,
Yeah.
they are.
Okay.
Lots of folklores.
Okay, and then finally, we're in the golden age of television. What you watching these days?
I binge watch a bunch of things.
Yeah.
I watch like Life in Pieces. You know,
Okay.
so I like funny things,
Sure.
right? So
Yeah,
Life
yeah.
in Pieces, I do like that. You know, I used to be Game of Thrones. I
Sure,
watch. You know,
yeah.
those are the kind of things
Yeah.
I watch. I also watch a lot of the sci-fi channels. It's interesting the kind
Yeah.
of stuff you see show up on that, as well as History Channel.
Right.
History Channel gives you a really interesting perspective on the planet that I never thought I would see.
Definitely. Well, I guess that's all we have today. I guess maybe it's usually where I give like an author or something a plug or something. I don't know. Do you have a plug or something people should check out to see what kind of work you're working on, or just
Yes.
buy GE microwaves? Yeah.
Look at Digital Twin.
Digital twin. Okay.
Look at Digital Twin, because
Yeah.
it's not only just GE, it's
Yeah.
an entire industry
Right.
building these twins of these systems.
Yeah.
You know, and you've got to look at that, because it's not just designed to help the asset itself.
Mm-hmm.
It actually taps onto every single thing. For instance, if the asset is going to be this much reliable, do you need the same insurance?
Mm-hmm. Right.
So would this affect the insurance company? Can I invest better if I know how, you know, a set of planes are working? So would that affect the stock market? This twin touches nearly everything, because the digital that's showing up touches the data economy. That touches everything in the world. Look at Digital Twin.
Digital twin. Computers are getting imaginations. So check out some of our past interviews if this is the first one of these you've seen. They're on Facebook, they're on YouTube, and then we're also a podcast now. So you can check us our back audio of different podcasts on iTunes, Stitcher, or wherever you get your podcasts at. And also, if you like this, give us a like, give us a review. It actually really helps. So thanks to everyone who was here. Thanks to Dr. Paris.
My pleasure.
And thanks to Social Pete. Thanks to everyone who was part of the conversation at home. And as always, be good to each other. Peace.